It's common ratio or common difference now? Anybody remember the rule for the nth term on Friday for a geometric sequence?
No, but it's in our notes.
It is. Daisy, you remember?
She doesn't. I know she does not.
Okay, I think I'm right.
Say it.
Is it the A of n equals?
Let's start. That's how you start all of them.
Yeah.
A of n equals.
Does
Okay.
it have the n minus 1? Or is that the other thing?
Times what?
R?
Where r is the common
Ratio.
to the.
N minus 1.
Very good. Okay, so we really need to know the first term and the common ratio. Hey, Hunter, what's up?
Hold on.
Got a awesome. Just throw it right on the pile right there. I've got a little pile started right there,
Oh.
right up there. Perfect. Thanks, buddy.
Yeah.
Okay, we'll see you later. Have a good day. Okay. So yeah, we need to know the first term and the common ratio. Okay. We had said that if something is a geometric sequence, it would take on the form y equals ab to the x. It would either show exponential growth or exponential decay. All right. So we had done a pretty good job getting through these. And you said we're on example number where? 4? We're on the fourth one? Did we finish the fourth one? Okay, so very good. Okay. So kind of a reminder on this one right here. When we didn't have the first term, we were given the third term and the sixth term. We said start with which one? The higher of the term or lower term? Higher. Start with the higher term. So in this case, the sixth term. And we went through that. So good. You guys want me to walk you through this again one more time just to put it back in your head, or you think we're good? Okay. Well, let's talk then. So guys, we talk about then this core concept. And this core concept here now is, you remember how we added up the values and we had a formula for arithmetic sequences to say what's the sum of this sequence? Same thing's true of geometric sequences. We can find the sum of a finite geometric series with the following formula. So S of n, the sum of how many terms? N terms is going to equal the first term, okay, times 1 minus r. What do you reckon r is? Common ratio. N is the number of what? Terms times 1 minus, or over 1 minus what? Okay, let's just do this. Let's start out with an example. Let's go 1. Let's triple these. Is that okay? What's the next one going to be then? Next one. And then my last one. Anybody know what 27 times 3 is? 81. Very good. Okay. Somebody do me a quick favor. How many terms are up there in that example? 5 of them, right? Add those all up for me real quickly. I'll try to beat you. 30 and 10. I got 121. Okay. What's that all add up to? Okay. First of all, do we agree that that's a geometric sequence? Okay. A geometric sequence of 5 terms. We started with 1. We're multiplying by what common ratio each time? Okay. When I just add these up here, kids, I get a value of 121. Okay. Now I want to show you that this sum works for what kind of a series here? Yeah. Okay, so here's what we're going to do. We're going to say the sum here of how many terms here, kids? This must equal my first term, which is what? Okay. Then it says 1 minus what? 1 minus r to the... Okay, so what is the common ratio in this, kids? So 1 minus 3 to the... How many terms were there, friends? Okay, so n must be 5. Boy, I think this is going to work. I don't know. Maybe it will, maybe it won't. All over what, kids? What is the common ratio? 1 minus... Okay, I need some help, kiddos. I need to know what 3 to the 5th power is. 243? So you guys agree that this is equal to 1 times, up top, 1 minus 243, is that right? All over 1 minus 3, which is I'll leave it like that for now, okay? Guys okay with the numbers we've plugged in so far here in that formula? We know my answer in the end is going to add up to what? We better add up to 121, right? Let's just see if that happens. Guys, help me out. What's 1 minus 243? So negative 242 over what value? 1 minus 3 would be what? Ooh, somebody go negative 242 divide negative 2 times that 1 up front. Did it give us what we thought we should get?
Yep.
Okay, so here's the deal, kids. Anytime you have what kind of a sequence? The sum of the sequence for the first n terms, or the sum of a finite geometric series, is defined by the sum of your terms equals the first term times 1 minus, what's r represent again? Common ratio to the nth power, where n represents how many terms you have over what? 1 minus r. So let's see if we can enact this here real quickly. This says find the sum of what, kids? One half times what? To the... Okay, let's write that formula down again. I'm going to write the formula down here again real quickly. So S of... How many terms are in this here, kids? This will equal... Okay, what goes out front again? So A of 1 times 1 minus r to the what? Or what? Okay. Kids, when I write stuff like this right here, we got to know, first of all, what the first term is, don't we? Okay. Well, the first term can be found by plugging in 1 right here, can't it? Okay, what's 5 to the first power, friends? 5 times half would be what? Okay, so from this right here, do we know that A1 has to equal, plug in a 1, so it would be 5 to what power again? 5 to the first, okay. That's 5, right? And then half of 5 would be? Okay. We need to know what r is equal to. Okay, which number is like the base and the exponent? So which number is really, do you see where the exponent is? What is my exponent up there? What's the exponent up here in this function? So what's the base? Common ratio is like the base. It's like what you're repeatedly multiplying by. Okay, so the value that's the base is going to be your common ratio. So what's r equal to here, kids? Okay. And then how many terms are we dealing? 6 of them. So n must equal what? Okay. So here we go on this, kids. We want to know the sum of the first 6 terms. I'm not going to find all 6 terms, am I? And then add them up. I'm just going to use our formula for this. So let's go with this. So the sum of the first 6 terms here, friends, here we go. What's your A1 term now? 2.5 times 1 minus what? 5 to the all over what? Okay, I need some help here with numbers. I need to maybe type it in this way. Somebody type in 1 minus 5 to the 6th power. Should be a pretty big negative number. 1 minus 5 to the 6th. Let's see. 5, 5, 25. 6, 25. 3,120. Is it negative 3,124?
Negative 15,624.
That's what I wanted to hear. Negative 15,624?
Yeah.
I forgot. I was only going to the 5th. 624, right?
Yep.
Divided by what, kids?
Negative 1.
Okay, so in this case right here, 5 to the 6th power, friends. 5 to the 6th power, what was that? 15,625? Okay, so punch those numbers. 15,624 negative divided by negative 4 times what?
1, 5, 6, 2, 5, 0.
How much?
9,765.
9,265?
9,765.
Yeah, that looks right.
Hey, Barson.
Yep.
Can I go?
Where are you going?
Soccer.
What time you dismissed?
2:30, but I have to get taken.
Yeah, you better go. Good luck.
Get tape or you want to eat?
You have to like kiss your wrist.
Can all soccer girls go?
Sure.
Sam, do you want to get beat up?
I have to get tape.
tape on
I have a golf team. I got tennis elbow.
You ever-
Elbow tape?
You ever seen Caddyshack?
I have, but it's been a while.
That reminded me of Rodney Dangerfield when the
Oh,
ball
my
hits him in his
goodness.
elbow. He's like, oh, my arm. It's broken.
Oh, yeah, that's right.
Try not to give up too much.
I'm not the only goal.
Well, you're the worst one.
Good luck, Daisy.
I'm kidding.
Good luck tonight. Good luck tonight. Can someone get the door for me on the way out?
What's she gonna do?
Yeah. Actually, you close the door. Oh, I gotta go get everything taken for golfing today.
Sam. Oh
I
my
had
God.
my-
I need a full body cast for the golfing.
Sam, one of these days, Daisy is just gonna unleash. You know that's gonna happen.
Oh yeah, I know.
It'll be on Caleb. It won't be on
Should probably
Sam.
send you an essay.
You'll need a full body cast tape.
That's it.
All right. How you guys feel? Again, kids, we verified right up here. We verified right up here that the formula for the sum of a geometric series, finite geometric series, was 121 by that formula, right? So if I say, can you give me the sum of the first n values right here using that formula? Understand how to use it here?
Yep.
Okay. What have we got left here?
Example 6.
Example 6. Okay, is that the last page there, kiddos?
Yep.
Ooh, this looks like a tough one, I think.
Oh, great. We're gonna be here for 30 minutes.
No, I promise it won't take 30 minutes.
I don't believe you.
Okay, solving a real life problem. I'm going to kind of read through this right here. It says you can calculate the monthly payment in dollars for a loan using the following formula. M equals L over the summation of the first how many terms?
T.
For 1 over 1 plus I to the K, where L is the what?
No.
How much you borrowed in dollars. I is the what? Monthly interest rate as a decimal. So if I said 25%, which is astronomically high, 25% as a decimal would be, yep. So I is my interest rate in decimal form. T is the number of what? It says calculate the monthly payment on a what?
5-year.
5-year loan, where we borrowed how much money?
20,000.
With an annual interest rate of what?
6%.
Okay, let's plug in what we know. Okay. M is what we're looking for. M is going to equal the loan amount, L. Do we know the loan amount, L, friends? 20,000.
Yeah, we do that.
Okay. So here's where things get a little tricky for us. 1 over 1 plus I to the K power. But, kids, how is T measured? Months. My friends, we're borrowing for how long?
5 years. Times by 5.
So how many months are there going to be in 5 years?
60.
So this T value up here is going to be what value?
60.
Okay, so this is going to be the summation. This is where things are going to get goofy for us, where K is equal to what value first? 1 all the way up to what?
60.
Okay, are you with me on this? Of 1 over 1 plus, I. I is the,
Or you have to do this stuff on
oh, absolutely.
Monthly interest rate.
this.
We're raising the bar on this. What's my percentage rate or my interest rate here?
6.
Well, what would 6% look like as a decimal, friends?
0.06.
All to the what?
Okay.
All right, my friends, here's the deal. The 20,000, that's no big deal, but here's what I want you to understand. Isn't this part right here a finite sum right here? It's every time you see this, that's like, okay, I got to add them all up. I got to add up the first how many terms. Now, here's the deal. On that bottom part, shall they make you find all 60 terms and then add them up, or is there a formula for this? Let's find this bottom part, because once I can evaluate this bottom part, we can take 20,000 and divide it by whatever, can't we? So let's roll with this. First of all, you guys agree that this denominator right down here is 1.06?
Yeah.
Okay. So let's work with the bottom here, this denominator, all right? So this summation here, I'm going to call it S. How many terms, kiddos? Okay, we need to know the first term, don't we? Well, guys, if I plug 1 in for K, what's 1 over 1 plus 0.06 to the first going to be?
2.6.
Careful. It's like taking this whole, this is like 1 over 1.06 right here, isn't it? Won't the first term be 1 over 1.06 to the first power? Or just itself there? Okay, so the first term, I'm going to write down as 1 over 1.06. Okay, that's your first term. Okay, now, this is to the one minus r. Do we know what the common rate is here?
No. Yes. No. 6. 0.06.
Boy, oh boy, oh boy, this is a tricky one.
It's not hard.
It's 6% per year, isn't it? 6% per year divided up by how many months?
Well, 60.
Isn't that 12 months in a year?
Yep.
So wouldn't that be like 0.06 divided by, I want to say 12.
0.005.
I'm going to double check on this one.
Divided by 60 would be 0.001.
Let's see. Your rate, kids. Remember that last example? I'm going to go back. This will help you. Remember what we said the common ratio was in this example right here? What was it? Because it was right next to the exponent. Okay. Let's use that same logic right here. Isn't the exponent right here, kids? So what the rate, well, I'm going to write this down. A1, when we put 1 in here, right, is 1 over 1.06, isn't it? True that?
Yes.
Okay. Isn't the rate also right next to this here as well? So the rate's also going to be 1 divided by what? Okay. Oh boy. We're going to have to use a calculator for this one. Somebody take 1 and divide it by 1.06 for me.
0.943396.
So say it again,
9434.
0.9434. I think 4 places is good. All to what power?
If you have not released the girls soccer players, please do so at this time. Thank you.
She went
How many months or how many terms, kids?
16.
And then this is going to be over 1 minus r, 1 minus 0.9434. Boy, I'm wondering about this right here, okay? So we think that this is 0.9434. That's this value here, right? Okay. Help me with the top. Somebody go 1 minus 0.9434 to the 60th power. I'm going to get my calculator out here too. 1 minus 0.9434 raised to the 60th. What do you all get?
0.9697.
0.9697. All over, what's 1 minus 0.93 or 9434? Because I get 0.0566. Do you guys get the same down there? Okay. I need someone to go through with a calculator and go 0.9697 divided by 0.0566 divided by 0.0566 times what there?
0.943.
Okay, I get about 16.1628. So this bottom value here, my friends, this bottom value is right here about what? This whole summation that we just did using our summation formula of a geometric sequence is about how much? Okay, so my monthly payment then would equal, how much was our loan again, kids? Divided by that summation value we got by formula, which was okay, so per month, if I take 20,000 and divide it by 16.1628, kids, I come up with about $1,237.40. That seems high to me.
Actually, I think we put the wrong number in for I, because it should be monthly instead of annually.
I think you're right. Yep, 6%. We should have been. That's a good catch. Take the value we've got right
I
now.
definitely did that for sure.
What do we have? 1,200. Divide that by. No, don't do that for me. You're exactly right. That should be 0.06 over. That's an annual interest rate, and we're going in what?
Months.
Okay, hang on a second. Do this for me. Go 0.06, 6%, and divide that up by 12 months. You're exactly right here.
0.005.
Okay, here's what we're going to do. I'm going to save this part right here. Let me do some stuff here. I think what we'll do, I'll have you take a picture of this. How's that sound? Instead of writing it again. Is that fair? Give me a second. Lauren, that was a good catch. Good job, kiddo. So, let me get rid of this.
Yeah, I knew that. I was gonna let you figure it out. So.
Thank you. I appreciate that. I gotta tell you, I'm pretty tired today on a Monday. So this should really be 1 plus 0.06 all over what, kids?
Whoa.
Okay, what'd you say 0.06 over 12 was? 0.005?
Yeah.
That's the deal. Very good catch. Okay. Okay, so this should have been, see where this 1.06 is, kids? This 1.06 should be a 1.005. Okay, so we use, see how we use this number the same as these in here? We're going to change all of those. Okay, so somebody do 1 divided by 1.005 to 4 places for me. What What is 1 divided by 1.005?
0.9950.
Nine nine five zero. Okay, and then this would have been to the 60th, right?
Mm-hmm.
That's going to work better. 1 minus 0.9950 here. Okay. All right, let me get this next line rewritten then. I think we're going to like this better. This would have been then 0.9950. That's this value. Okay, somebody do 1 minus 0.9950 to the 60th and tell me what that is. .2597.
Mm-hmm.
I can tell you right now the bottom's 0.005 down here. So I need someone to take and calculate this. This will be our right one here. So you're going 0.2597 divided 0.005 times what?
$51.6803.
51.6803.
Yep.
Okay, so instead of doing 20,000 divided by what we had, we've got to figure this in terms of monthly interest. So it'd be the 6% spread out over 12 months, which is at 0.005 per month, or 0.5% a month. Okay, so let's get rid of that 161628 here. So we're going to divide by how much? Somebody divide that out for me.
$186.99.
Okay, that seems a little more like it to me.
That's a lot of stuff.
Yes, it is. Do this for me. Take that 386.99 now. Take that times 60. What do you guys get when you multiply that by 60? 20, 23,000. So on a $20,000 loan, you actually ended up paying back how much? So the bank profited approximately how much money? Okay. All right, kids. Yeah, Lauren, good catch there. Thank you so much. Let me stop this here.